What if I told you there's a version of reality where your entire life, every moment you've ever lived, every person you've ever loved, every memory etched into your mind was nothing more than the flicker of a cosmic accident, not a dream, not a simulation, something far stranger? What if you're not the result of billions of years of evolution, but rather the spontaneous alignment of particles forming a single thinking brain alone in the void? In physics, the impossible isn't always impossible. Sometimes it's just unbelievably improbable. And in an infinite universe, even the unthinkable becomes inevitable. This is the unsettling foundation of the Boltzmann brain hypothesis. Named after 19th century physicist Ludwig Boltzmann, who tried to make sense of entropy and the arrow of time, the theory begins with a simple premise. If the universe is governed by entropy, a march toward disorder, then order must be a temporary fluctuation, a rare statistical accident. Now imagine this. Given infinite time and a universe in thermal equilibrium, a sea of randomness and decay, atoms will, purely by chance, organize into anything. Not often, not quickly, but eventually. You could get a snowflake, a television, a star, a living cell, and once in a blue eternity, a brain that contains thoughts, that thinks it's alive, that remembers a past that never happened. And yes, we mean a physical brain, not metaphorical, not symbolic. A literal structure of particles, molecules, atoms, quantum fields, briefly and bizarrely arranged into the shape of a functioning brain. You might be wondering, how could a brain survive in the vacuum of space? Humans can't even be in space without a suit. But this isn't about survival. It's about structure. This brain wouldn't be alive in the traditional biological sense. No blood, no breath, no body. It wouldn't need to survive more than a moment. All it takes is for the atoms to line up just right, long enough to simulate a fleeting moment of awareness, a spark of thought, before it dissolves back into the cold fog of entropy. It might exist for a billionth of a second, or a flash of a flash of a flash. But if it thinks, even once, even wrongly, it counts. Here's where the paradox begins to fester. If our universe lasts forever, and if conscious structures can emerge by random chance, then Boltzmann brains will eventually outnumber beings like us, who arise from stars and evolution and struggle. Our world, our history, our reality are but a fleeting anomaly in the ocean of cosmic time. And once the final civilization fades and Earth is gone forever, the odds of recreating that same intricate dance of life are astronomically low. But the odds of a single brain, briefly flickering into awareness through random fluctuations in space-time, are far less demanding. And so, in the long run, those lonely minds may vastly outnumber us. Why? Because it is far easier to spontaneously form a single brain than it is to recreate an entire star system, ecosystem, and evolutionary chain. The odds of a universe like ours forming from randomness are astronomically low. But the odds of just a brain forming, as small, strange, and disturbing as that sounds, are higher, relatively speaking. And in an eternal universe, anything that can happen will happen an infinite number of times. So statistically, you wouldn't be a flesh and blood being on a stable Earth. You'd be a floating, momentary illusion of a being. You'd be a brain, hallucinating a life it never lived, a world that never was. And that means, if Boltzmann brains vastly outnumber real humans, then the odds suggest you might be one of them. Let that sink in. This is not a simulation hypothesis. This is not solipsism. It is a physical paradox, born not from philosophy, but from statistical mechanics. The terrifying thing is not that it might be true. The terrifying thing is that it might be logically inescapable. Because if the conclusion of your theory is that you're probably a Boltzmann brain, then it also implies that all your thoughts, memories, logic, and scientific reasoning are hallucinations. And if that's the case, then you can't trust the reasoning that led you to that theory in the first place. That's what's known as epistemological collapse. A theory that tells you not to trust your own thoughts is a theory that invalidates itself. It's not just unsettling, it's logically self-destructive. That's why many physicists argue that any model predicting a universe overrun by Boltzmann brains must be flawed. Not because the implications are emotionally disturbing, but because such a model eats its own foundation. If your theory leads to the conclusion that reasoning itself is an illusion, then you have no rational basis for believing in the theory at all. It's like building a calculator that tells you every calculation is wrong, including the one you just did. At that point, the calculator isn't just broken, it's meaningless. And so modern physics continues wrestling with how to avoid this fate. Whether it's through rejecting eternal inflation, rethinking entropy, or reimagining the nature of time itself, one thing is clear. We are trying to build a model of the universe where Boltzmann brains don't win. Because if they do, everything unravels. So the next time you lie awake at night, unsure if any of this is real, remember, the atoms that form your brain don't know where they came from. They don't care if they were born in a womb or formed in a quantum fog. They only know that they're thinking, and if that's all it takes to be you, then how do you know you didn't just pop into existence right now? Because when you give the universe infinite time and space, even the rarest events become inevitable. That's the terrifying beauty of what mathematicians call almost sure convergence. Given long enough, anything that can happen does, even you. Perhaps as a floating brain in a dead universe, hallucinating an entire existence that never truly was. And if your mind is still spinning, wondering what else inevitability might have in store, you'll want to watch my full breakdown of Almost Sure Convergence, a deeper look into how the laws of probability can make even the most impossible things unavoidable. You'll find it linked below. And if you enjoy unraveling questions that shake the ground beneath your thoughts, subscribe and let me know in the comments. Are you still sure you're real?